ஓரியன்டேஷனும் ஏதோ ஒண்ணு போயிட்டு ஃபுல் ஸ்க்ரீன் வச்சுர்றா. அதாவது இந்த 3 டாட்ஸு ஏதோ ஸ்பாட்லைட்ன்ற மாரி ஒண்ணு வச்சுரு. சைடுல இருக்கிற பேர்லாம் வராது. ஏய் மீட் லிங்க் இல்லடா, மீட்லடா.
Hello guys, can you hear me? Hello, guys. Good evening to all. We are so glad that these many people who are interested in joining our workshop, even in your holidays. We appreciate you all. Firstly, I would like you to give a brief intro about our workshop and the agenda you will be learning in our 4 days workshop. In day one, we will cover about the basics of workshop. In day two, we will start about CoppliaSim, a robotic simulation software. You don't need to worry about it. We will teach you from the scratch. In day 3, we will come to know about Lua script, which is used to control the movements by coding. Day 4, as mentioned in the poster, stay tuned, guys. At the end of every day, we will give you a task which you should complete and send to the members whom we will say in the WhatsApp group. We will send the best work, first 3 of them will be posted in our official Instagram page. At the end of every day, we will be giving you a task in which you should send to our group members with your Insta ID. At the end of this day, we will conduct a quiz from today's topic. Stay tuned and keep learning. Now, today, this is handled by Nishwant and Bhavana, and myself, Vidya Vashni, third year ECCPS.
Okay, guys, let's make this interactive workshop and let's start the workshop today. Over to Bhavana.
Hello guys, I am Bhavana from second year ECE department. Now, as Vidya Akka told about today's workshop, we are going to see about the basics of robotics today. So, what is actually robotics? Robotics is actually an interdisciplinary field which covers different fields like designing, constructing, operating, utilizing many fields, etc. It actually combines engineering, computer science, and other which creates mission and performs traditional tasks which are done by humans. Now, there are different applications of robotics, which are as described industrial automation, healthcare and medical robotics, autonomous vehicles, aerospace and defense, service robotics, agriculture, smart homes and AI assistant, education, research and development. Let us look into the first four topics which are essential in robotics. First one, industrial automation. Industrial automation is a widely used manufacturing which are actually in assembly, quality control, packaging, and material handling, etc. Here we can see a picture of a pick and place robot. Next comes the healthcare and medical robot. I guess you have heard many of these robots which actually make surgeries instead of doctors. And next comes the agriculture. In agriculture, we are using drones for transporting and also for spraying pesticides, fertilizers, etc. Next is automobile industry. As we know, in automobile industries, the parts are huge and it is difficult for humans to carry. So robots have come into actions which make them easy and make the manufacturing faster. Let's move on to the next topic. Next, types of robots. I just have a doubt. Have you ever seen these type of robots in your daily life or come across these things? I guess you have come across it. So first one we'll go into articulated robot. So articulated robot has many joints which are mainly for accessing in different 3D spaces. It actually deals with all the X, Y, and Z axis. Next comes the SCARA robot. SCARA robot is designed especially for speed and rigidity. It mainly focuses on horizontal planes like X and Y axis. The third one, the main important one, is Cartesian robot. It is actually a linear movement based system. It deals with all the three axes, X, Y, and Z, which creates a rectangular workspace. The fourth one is Delta robot. Delta robot has a high speed and precision. It mainly deals with the tasks like packaging, assembling, and sorting out tasks. The fifth one is cylindrical robots. It is actually two linear joints which are joined with the base and other with the end point. It actually covers the surface area of a cylinder. The last but not the least is a collaborative robot. These are the ones which work along with the humans and help us to achieve tasks easily. So I guess everyone have got the points which I have shared. I guess you don't have any doubts. Let's move on to the next topic. Next is history of robotics. History of robotics actually, like each and every field has its own history. In the same way, robotics has also an history from during the Renaissance and up to the current age. So, in the early period, during the ancient times, in the Greek astronomical calculator was actually considered as a history of robotics. Next, during the Renaissance and Enlightenment, Leonardo da Vinci has designed many automations and mechanical devices which made us to achieve robots-like structure at present stage. Next, during the Industrial Revolution, huge machineries have become the great ones which make the industrial automation as well as the robotics have a boom here. Next, during the 21st century, mostly everyone might have been aware of it. We have many pick and place robots, and as we discussed earlier, industrial automation robots. These have become a manual one during the early of the 21st century. In the past decade, there is an extraordinary changes, including AI along with robotics. Now, at present, we are having a robot with AI generated, which made the works easier for us. This is the evolution of robots from the Renaissance and to the current age. So next one, we'll get into the contributors for the robotics. First one, Nikola Tesla. And the second one is Isaac Asimov. First, we can look into the contribution made by Nikola Tesla. So Nikola Tesla actually gave us many opportunities by dealing with wireless communication, Tesla coil, AC current, teleautomation, and feedback mechanism. Here, wireless communication has made a greater achievement to make the communication have a vast changes. Next, the Tesla coil has a high frequency transformer circuit, which makes the wireless power experiments and so on. Next, in the AC currents also he had made many such things, and teleautomation is one of them. Feedback mechanism is actually a hinted idea of closed loop systems where machines adjust their behavior based on the feedback. So for the next topic, I give up my thing to Nishwan, one of my teammates.
Hello. Hello, guys. I hope I'm clear and audible. And is my screen
Yes.
okay? Okay, guys. I hope So far, we got your attention pretty good. And I am Nishwant, second year ECE. Let's jump right into the topic. And let's see about the second key figure in our field of robotics, Isaac Asimov. He is one of the pioneers in this field, and he was originally a sci-fi writer. He with a PhD in biochemistry. He had nothing to do with this field, and he is not a scientist. But he foresaw many developments in this field as a sci-fi writer, which was critiqued on his time, but later people accepted his work. His remarkable work in this field of robotics includes the draft of three laws of robotics in his sci-fi story Runaround. The name was Runaround, and it was published on a sci-fi magazine during his time. Okay, let's see about the laws. First law: robots should not harm robots should not harm a human being via its action or due to its inaction. It sounds pretty simple. A robot should not just see there and sit there and see a person getting hurt, or it should not hurt a person, right? And both of this both of these outcomes should be avoided at any circumstances. We all know that. And let's go to second law. Robots should not disobey the given orders unless until it contradicts with the first law. For example, let there be a person A, and he is very depressed and has some suicidal thoughts or whatever, and he orders his robot to kill himself. The robot should not do that because human life is obviously more valuable. And in these circumstances, the robot should not obey his order. It should violate his order. It should override his order because it contradicts the first law, right? It hurts the human being. I hope you guys understand. Let's go to third law. The robot always should protect itself and avoid performing tasks that hurt itself unless it violates the above two laws. Because if the robot doesn't exist in the first place, like it hurted itself or it undergoes a self-destruction or something, who will protect the human being? Who will protect his master? Nobody will be there, right? So under all circumstances, it should protect itself unless until it contradicts with the first two laws. Now, before before seeing the zeroth law, which was introduced and added with the original three, after a while, let's see about a scenario through which we can understand or perceive these laws very well. And this is the scenario given by Isaac Asimov itself on his story Runaround in the magazine. So there are two people, A and B. They are miners actually, and during mining there was an accident and A got seriously hurt. He is on his life support, and the life support is out of power. It needs a mineral to power it, and they knows that the mineral is available in a short distance in a nearby pond. They detected it. So the person B orders a robot named as PE to fetch the mineral from the pond. And person B is waiting for a while, and the robot is taking too much time. So he got pissed off and he went himself to check the pond. But he finds that the robot was going in circles round and round around the pond without entering into the pond and fetching the mineral. You guys know why? Can you guys guess why? Because that mineral, the robot actually scanned the pond and found that the mineral is both harmful for human being as well as for the robot. So the robot was originally ordered to just go fetch the mineral. That's it. So now in this scenario, the orders of the robots contradicts two laws. The second and third laws are contradicted here. According to second law, it should obey the orders. But if it enters the pond, it will die. It will be harmed. So it contradicts the third law. Since it contradicts, it cannot take the proper decision, so it goes round and round around the pond. And this person B, he wants to save his friend, so he jumps into the pond in order to fetch the mineral without knowing that it is harmful. While he jumped, he got affected by the mineral, and the robot saw it and immediately dived into the pond and saved person B, violating the 2 and 3 law, second and third law, and for the sake of first law. By this scenario, what he wants to convey is these three laws are actually oversimplified. The three laws he gave are actually oversimplified version. They holds up for simple situation, but not for complex situation like the above one. So, and later, zeroth law was added to the three. The three laws were dealt with the well-being of a single human being, and but the zeroth law considered the whole humanity as a whole. It said that the should not robot should not harm humanity due to its action or inaction. That's what it said. It's pretty basic. Then these were the first set of laws of deduced in the field of robotics, which guides the behavior of the intelligent robots. Also dealt with the ethics and sets the boundary for the robots. And during his time, it was only fiction. And later, after further development in our field, the scientists actually accepted these four laws. Nowadays, there are lots of development and lots of new sets of law were drafted for the field of robotics by several institutions and organizations. Such examples are IEEE principles. They majorly focus on engineering and EV7 requirements, EV7 AI rules. In short, they focused on trust and safety of robots. Asilomer AI principle. They are for the longer term AI safety, which are implemented in robotics. And Japan three laws of robotics. They deals with the basic human and robot interaction. Any doubts so far? Okay, let's move on. Components of a robot. Okay, let us assume we guys have to build a robot for our science fair, for our project. We have to get the first prize on all circumstances. So we decided to do a robot, and we decided to do a obstacle avoidance robot. Basically, what it does, it goes, if there is an obstacle in its path, it will move and choose another path and move. This is capable of moving and avoiding the obstacles in the path of the robot. So we have an idea now. We have to implement it. So you have to buy the components, and you guys will run to the nearby electronic shop and hastily you will buy the components. But hold your horses. First of all, in order to do the project, we have to know about the basic components of a robot. Let's go one by one. Okay, first of all, we need the robot to move and function properly, for which we need power. Obviously, without power, nothing will move. And for that, we need a power supply which is capable of supplying sufficient power to all other components according to their power rating, no less, no more. And example of these are battery packs, power supply modules, and other stuff. Pretty basic. Now our robot here there is a power supply module, power supply system on the back of the robot, as you can see. Now our robot has power. It is capable of doing many things. Now it had to, if it detects a obstacle on its path, what it should do, it should take the alternate path, right? Further, it should make some decisions and change the direction. But like human beings, like we have brains, we can take alternate paths with our own decisions, but it cannot do that. For that, it needs a brain. It needs some sort of brain, like a component which acts as a brain. That's basically the controller. Controller is a component like brain in human beings, which process the input got from the surroundings and takes decision accordingly, and gives the electrical signals to the output components like actuators and stuff, which we will see later, which we will see in short while. Example of the controller, like microprocessor, feedback systems, and microcontrollers. Here in our robot, in the robots depicted here, we used Arduino Uno 3, by the way. It's a microcontroller. Now we have a brain to take decisions. We can move. We have power to do that. But let us say let's take a human being as example. We have to move in a room, or we have to move in a terrain. What we need, we need to have an idea about the environment first of all, in order to take some steps or whatever. You need to perceive it first of all. For that, we have sensory organs, right? We have eyes, we have ears, with all these inputs, our brain gets data, and then it creates a own picture of the surroundings, and it takes the decision accordingly. But robots doesn't have eyes and stuff, but they have sensors. They act as sensory organs of a robot. They are equipped with many types of sensors. There are a variety of sensors. Let's see one by one. There are like proximity sensors, which detect object without actual contact. Um, for example, IR, ultrasonic, and PIR sensor. These sensors usually emit IR and ultrasonic are basically same with principle. They usually emit a ray or a wave, and when it is reflected, they read it, and accordingly it will give the input. IR sensor uses infrared radiation, but ultrasonic sensor uses ultrasound waves. Here in our robot, we used ultrasonic sensor that we can see there depicted as a sensor, and vision sensor. It's used to get the image of the surrounding which is around the robot. Example, camera. Then let's go for gyroscopic sensor. Gyroscopic sensor are used to maintain the balance of the robot. If it moves in a rough terrain or something, it needs some balance. Otherwise, it will fall, and it will lead to property damage and stuff, right? So it needs a balance. For example, there is a force balance accelerometer. That's a sensor which maintains the balance by providing counteraction using a feedback loop when acceleration detected. For example, if there is a sudden acceleration due to a fall or rise, it will detect that, and it will take the counteractions in order to maintain the stability. Let's go for touch sensor. Touch sensor detects the pressure changes or pressure variation upon contact, and temperature and humidity sensors. They are, by the name suggest, it obviously measures or reads the temperature and humidity in its vicinity. Likewise, there are more and more sensors, and these sensors, all above sensors, are capable of giving values, but we can classify these values majorly into two types: digital and analog. Digital values, they are basically only two: 0 or 1. 0 is for low state, 1 is for high state. They are their response time is very low, but the processing speed of digital values are much higher because they no need any converter in order to convert them into something, or we need to process. We can actually get the value raw from the sensor if it's a digital value, and we can process it. Microcontroller can process it very well. And the digital values have low precision compared to analog values, because with only two figures we cannot quantify or measure anything, right? On the split side, our analog value, it's a range of numbers between a defined range. It's like between a defined boundary, it will return multiple values based on what it reads. It has more precision, as we can get a variety of numbers, and we will get an idea about the change in the surroundings. It needs a converter. We cannot actually process the analog values right away. We need a digital converter to convert it. And analog values has a high response time, but the processing of analog values requires more time compared to digital values. Okay, let's go to the next component. Our robot has power, has mind, has inputs. Can it move now? No, obviously not, because the brain can perceive and can process and gives the output signal, but there is nothing to receive the output signals, right? There is nothing to receive the output signals, so the robot obviously cannot move. There should be something that obeys orders and move, right? That's actuators. Actuators converts the electrical signals or electrical energy into mechanical energy, but by their means. There are multiple types of actuators, like mechanical actuators, hydraulic, pneumatic, thermal, and piezoelectric actuators. They are used according to the needs of the robots. Here in our robot, we used hobby gear motors there and a servo motor, right? They are denoted as actuators, as you can see. Example are the servo motor, as we said, and the stepper motor, linear actuators are also there. And next, we bought all of our components now for our science fair. Now, yeah, we are gonna like crack the science fair or whatever. Now we have to assemble them. On what on on what we will assemble them? We need a base. We need a base in order to assemble them. We need to put all these into one single robot. We need to put all this in a single robot, right? For that, we need a base, and that's basically chassis. Chassis is basically a base. It houses all the components, provides structure, mechanical strength, and stability for the robot. It also provides shelter or protection to the components from the elements of the environment, like dust, dirt, water, or something. There are various types of chassis, wheel, tracks, and legs, obviously many things. We can 3D print them according to our needs, or we can buy them readily from the shops also. Okay. Is there any doubts? Doubts? Before going to this topic. Okay, moving on. Types of robotics. Autonomous, manual. Autonomous robots are self-controlled robots. They are capable of taking decisions and acting on their own, using stuff like feedback loops and AI. They are like modern robots, and they do not require any sort of human interaction in order to process the inputs and stuff. Due to these many components, in order to do these stuffs, they need to house many components, and they will have a big backend work, right? So they are usually complex and comparatively slow, and they can adapt themselves based on the surroundings and input data and their past mistakes, and they can correct those things. But manual, here human is required in order to process the input and give the output, but they are fast. Why no? Because the robots is doing very less job. Our human is itself processing the data, so it is obviously fast than the autonomous robots. But it cannot adapt to the surrounding. We have to update it on our own once in a while, and it's comparatively simple than autonomous robotic systems. And we have mobile robots. Name itself gives a thing. As the name suggests, they are the robots which can undergo locomotion. They can move from one point to another point in a given space. There are of many types. Based on chassis, the base used, as I told earlier, we can classify them into wheeled, tracked, or legged. Wheeled chassis or wheeled robots are very effective in leveled terrain. They are energy efficient. But in undulated or uneven terrain, we can use legged or tracked chassis. Tracked are more durable than the other two, by the way. And legged chassis. By the leg, it can be bipod or quadruped or hexapod based on your requirements. And let's see about their applications. We can use for warehouse logistics or navigation or travel also, and they are used in space exploration mission also, like rovers and landers and stuff. The next type, humanoid robotics, which inspires us the most and takes a lot of our interest, right? They are robots which looks and acts like human. They have a torso, head, hand, legs, decisions like human. They are tools in order to achieve those things. For examples, there is Asimo from Honda and Sophia from Hanson Robotics, which you know very well. It was on Tamil textbooks also, and many other textbooks. It's a pretty famous robot, and it once said about killing all human beings. And Atlas from Boston Dynamics. Next, drones. So far, we have been traveling in the terrain itself. Let's just fly now. Drones are like unmanned aerial vehicles which don't need human in order to drive them or whatever, which can be controlled using controller, or it can navigate on its own also. Both are also possible based on the model. Based on the drones can be classified into three types. Multi-rotor. These drones consist of more than two rotors, usually four rotors, and it can be 4, 6, or 8. And based on the number of rotors, we have to configure them in order to provide much stability. and fixed wing. They have wings like an aeroplane, but they requires runway and some structure in order to take off and fly. But it can cover long distance compared to the multi-rotor thing. And now we have hybrid thing. They do not require any runway, as they can vertically start their flight and they can fly, and it can also cover more space compared to those two. It's like a hybrid of those two, as its name suggests. Next, I will hand over this to Bhavan.
I hope you guys have gone through these topics and understood it well. Just before moving on to the next topic, I'll just ask you a few questions. It's not just so difficult or something. Up to now, we have seen many robots types and applications and histories, etc. So I guess any one of you can share about your experience or which robot you have seen or the ones you have heard before coming to this workshop. I guess each and everyone can share about it. Hope you guys can hear me.
Yeah, Bhavana. Guys, make it interactive. The session goal is for you only, so feel free to speak anytime you want. Just raise your hand and you are feel free to speak.
At least a few volunteers are asked to say something. Any one of you?
Guys, is that mean no one has seen any robot in their life or something?
Guys, we have shown a
Hello?
trending robot in our slide. You can share about it.
Can you hear me?
Yeah.
In real, but I've seen some videos of robots. Like I have seen this legged robot, this mobile robot once. Like Dhoni, right? He was giving a high five to like dog shaped legged robot. That was what I saw back.
Yeah, it was one of the famous robots, famous legged robots that was made in IPL. I thought you'll all guys speak about that. Any other robots, humanoid robots are there? Yeah, we have seen Indra movie, right?
Actually, Endiran was the first movie which made the robotics field to know into the locals of people from city to the villages, I guess.
For me,
I
my
also
inspiration
get
to
some
robotics are
answers
Big
from.
Hero 6, Baymax. I hope you all know about Baymax, right? You drop.
I also can see many answers from the chat box. Well done, guys. So, okay, let's move on to the content. So now, up to now, we have seen the basics of robots. Now let us move on to the some technical part. So first, we are going to see about the kinematics and motion in robotics. The first one is the most important one, DOF, was actually is not much bigger word. It actually refers to the joints. So we know our arm, right? So in our arm, there are many joints like fingers, arm, wrist, and elbow, shoulders, etc. Each of us help to move and make us to take something which is at a different space, like from x-axis, y-axis, z-axis in the spherical surface area or in the plane of something, etc. Now, if you guess you have only one joint and you just want to pick up something from one place, it is actually quite difficult. If we consider a circular motion, we can only acquire it from the circumference of the circle. If we have two joints, it is only with the plane. So when we compare these two joints and we have a di- huger difference and we get to acquire much area. So as the number of joints increases, the area which we can acquire is increased. So when three joints is there, we can actually acquire to get used to the z-axis also. In the same way, as we compare to the arm of our body, we also have the same in the robot. As we can see in the picture, there are three joints in the robot, which actually means it is a 3DOS. So the greater the number of joints, the greater is the flexibility and greater is the adaptability. That's the main reason for the importance of degrees of freedom. So next one.
Guys, regarding this kinematics, let's again go to the manipulator arm itself. Our arm has around three joints, right? It has 1, 2, and 3 joints. So does it can move in three angles can be moved at once. So let us assume that we want to move the end effector, that is the grabbing thing, or the end effector. We have to move this from initial position to final position. Say A and B. A is given; it's at origin. Let us say, and we are given with a set of angles and length into which we have to move the arm, and we are asked to find the final position, the coordinates, final coordinates. Let us for simplicity we can assume this happens on just a 2D plane, not 3D. XY first XY coordinates will be given, and the final x2 and y2 should be found based on the given angles and length. This is what forward kinematics is. Pretty straightforward. And for inverse kinematics, this is basically the opposite of the forward one. We will be provided with the initial and final position, and we have to find the angles to which the robotic arm should be moved at each pivot point or joint in order to achieve the locomotion and to reach the point B. And and based on the principle, the inverse is found inverse kinematics is pretty hard because there are many ways to achieve a single locomotion and reaching point B, right? There are more than one way in order to reach that, in order to do that. So that's the forward and inverse kinematics. Any doubts?
Let's move on to the next topic. It is actually based on ethics and safety in robotics. Actually, to be frank, if we look into any of the objects or some things which we buy in our daily activities, we first look into whether it is safe or harmful, whether we can use it or we should not use it, how to use it, what is the user manual for that, etc. In the same way, for the robotics, we have to look into the ethics and safety. The first and foremost thing to be followed is based on the laws which was previously given by Isaac Asimov. So it actually encompasses the ethical consideration and safety measures involving in design, development, and etc. It, it is not only about how we deal with, it is also about who manufactured it and how he manufactures it. There must not be any damage or anything either for the users or for the producers. So the first key points which are included in this is safety protocols like ethical impact assessment. So ethical impact assessment plays a great role while we speak about the ethics. Next, addressing issues like bias, privacy, and accountability. In the present world, actually, like addressing bias, privacy, and accountability has been a great demand. Many of them are unaware about where to address these things. While purchasing a robot or manufacturing a robot, These things must be specified and noted in a caution. Next, transparency and accountability. In the present generation, robotics have been under the cloud control mechanism. So, everything from the scratch to the end, there must be a transparency how it is made, what are the things it can do, what it is doing, etc. And the accountability plays a greater role in the management and side. Bias and fairness. While talking about one thing, that is actually either for or against, that is bias. Both advantage and disadvantages must be shared while specifying the fairness. We should not have any surpassing of disadvantages because the fairness may sometimes cause a disadvantage. Next, privacy and data security. So, actually, speaking of this, the privacy in the present world, especially in social media, the privacy is what we think of. In the same way, in robotics, the privacy is the necessary one and data security. When there is privacy, the security must play a major role. There must be some walls or some protection for data to be not be captured or stolen by others. So these are actually the safety protocols need to be followed for each and every robot or robotics to be made. I guess you understand these things. So do you have any doubts regarding this?
This they are having no doubts. Guys, I'm repeating it. You can speak anytime you want. You can ask any doubts. You can share your comments on what the slide you said. Like that, you can speak whatever you want. Just make it as a discussion, not as a single person teaching everything.
Guys, are you there? So I guess you have seen the IPL robot dog. So can you guys say something about that or some kind of things like that?
Guys, you can all talk. Just turn on your mic and say whatever you know. IPL robot dog is a very common thing. If we speak about IPL, everyone should turn on your mic, right? Else, if what's the respect towards IPL we are showing?
Anna, they are watching Tala, the IPL for Tala and RCB and stuff. They are not watching some robots and stuff like
Bro, even me watching IPL for Tala only, bro.
that. Accepted, accepted.
Even if we say that we are watching for Tala, Tala is also had made something in that robot, right?
Yeah, I think Vishal talked about that particular thing.
Yes, yes.
Yeah, can you please let us know that whether that robot is of remote controlled or battery?
Remote control.
Okay, remote control na. How are you maintaining it? with a long distance, because the robot just enters inside the ground and reaches till the pitch which is exactly at the center of the ground. And how are you controlling it? Like the distance I'm asking.
I don't know accurately, but I guess it's like it should be nearby. I have seen that robot in person, so uh, I at least the robot should be visible to the guy, and I don't think it should be more than maybe uh, 50 meter.
Okay, I'm actually a cricketer, so as per the dimensions of the ground, minimum it will be some 65 70 meters from the boundary line to the pitch. So how are you controlling it?
Bro, when it comes to a remote control or whatever you say, you can see some drones that are flying around several meters. We can control it even. So it's not like the control, you can increase the range of control as much you want. It depends on the system you are using. As they're going for that much costly robot, they will mainly focus on the controllability and maneuverability of that particular bot. So distance doesn't matter. They'll manage it for the remote control, whatever they are using. So the thing what I'm saying is, if you are having, uh, it's a basic thing, right? If you are having a 400 rupees remote control car and a 1500 rupees remote control car, to be making it easier to understand, you can see the difference between them for the range. So it's not an impossible thing to make a remote control thing for around 70 meters. We are controlling satellites, rockets, and its movements from even Mars from here. So it's not that kind of an impossible thing. So if they can invest, they can do this much of a robot. The thing we have to be very cautious, and we have to see like, wow, what the thing is, its maneuverability. So it's a four-legged bot, but it can move in various directions, and the algorithms, even the environment prediction. See, if people are standing around them, it should know like this is the environment. So the mapping and localization is the main important thing when it comes to a movement of the bot. So controlling it would be a simpler task when compared to the maneuverability and its movement.
Okay, thank you for it. And what are the components that you use and the concept, main, maybe the overall concept behind it?
Yeah, I'll hand it to Nishwant because he has explained about the major components of a robot. The major components are the main thing, but they'll use the advanced version of this in an industrial matter. Whatever
Like
we are
I'm
studying
asking,
here.
sorry to interrupt. I'm asking that, like, I understood the components which are used inside a robo, but the thing is, what is the specific component that you use to control it? It is like
So
something
the
sensor,
thing,
something like that.
there is a boundary line between what we are doing as a prototype and an industrial one. So if we go for a normal motor, even we are having a servo and a stopper, which makes the difference between our normal and the industrial use. So when we go for industrial purpose, they'll use some valuable components that are having some patents or something. They'll be unique. So if we want to know how the robot is built, we have to go for the manufacturer and how to know what are the components exactly they have used. So we can't say like from our knowledge of understanding they'll be using a controller, directly microcontroller or something. They'll be having some kind of programs or algorithms to make it move. And it's not like exactly it's based on what we are doing as a prototype from our knowledge. It's beyond, right? That's what I'm saying. When it comes to industry, we can't say what they are doing. They'll be proposing new and new algorithms and different methods of making a bot move. So that's why I'm saying it's not a particular thing to say this is the particular thing they have used in that bot like that. If you are asking how to make a prototype of that bot and what are all the components required for that, it's basic. the major components that we have discussed in the workshop. These are the main components, and it depends upon what you are going to apply it for. You can modify. There are a lot of controllers, a lot of actuators, and a lot of motors available, a lot of algorithms there. So if you are going to make a prototype of it, you can use whatever major components you want. But the major components should be there. Without them, the robot would not be complete. That's what the scope of this particular day to reach out to you.
Thank you, buddy. Thank you.
Guys, feel free to ask any questions or any this kind of discussions. It will be helpful for us to, like, we can speak out to one and others. Like, see, if this time Nandakishore spoke and then Harishma replied, like that we can have it like a discussion. So just turn on your mic, speak anything you want related to robotics. I'll make it clear. Over to Tivarshini for the next one.
Hi guys. About this day, we are going to conduct a quiz, which we will be sending in the message. The top three scorers in the quiz, we will be tag them in our official Insta page. So enjoy attending it and happy learning. Thank you.
Guys, you can sign into the link we have provided. Just go answer out all the questions there. I think there is about, how many questions are there?
20
20,
questions.
yeah.
Uh,
20 questions are there. Just it's a very basic questions only. I have done that. So just go through it. It's very happy to do that. I'm speaking as a what can I say? I have also attended that quiz. So I'm saying it's very interesting to do. So just go do that, and the top three scorers will be tagged in our Insta page. So the thing is, from tomorrow we are going to learn about how to enter into CoppliaSim and what are we are going to speak. So today was a session based on an introduction to robotics and its particular views, like what are all the major topics and other things like their kinematics. So this is a basic for a day zero. From tomorrow, we'll be entering into the software CoppliaSim. So make sure you have all installed CoppliaSim Edu software in your laptops, and if possible, you can do along with us, or else we have streaming. We are streaming this particular Google Meet in our YouTube channel, so you can always rewatch the video, do along with us, and you can make the output. So the tasks for today is to do this quiz, and for the upcoming days, we'll be giving you the task. You have to complete it, and you have to send the finished outcome as a recorded video with your Insta ID tagged below. So stay tuned with us for the complete workshop. Hoping you all will come tomorrow also. So shall we sign off, Rashid?
okay.
Okay, guys. Now you can leave. Make sure you will come. You all come tomorrow for the introduction to our CoppliaSim software. So bye, guys. Guys, you all can leave now.